All right, get ready to dive deep today because we're going to be talking all about deterministic UUIDs.
Ooh, very cool.
Yeah, specifically how to create them using something called UUIDv5 and the X.500 standard.
No,
And we're basing our deep dive on a blog post by John Mush. He goes by Zaven online.
okay.
Now, if you're a programmer dealing with systems that may need to share data at some point down the line, even if they're not connected right now, this is definitely for you.
Absolutely. And what I love about this post is that John Zaven really knows his stuff.
Oh, yeah.
Oh, yeah. He's a really experienced full-stack developer. He's worked at places like Red Cat Systems and Fidelity Charitable.
Wow, those are some pretty big names.
Not small potatoes at all.
He's probably seen a lot of data management issues then.
You know it. Which is why his insights on deterministic UUIDs are so valuable.
Okay, so let's get right into it.
Let's do it.
What are deterministic UUIDs? And how are they different from the regular kind?
Okay, so think of it this way. A regular UUID is like rolling a dice.
Okay.
Random, unpredictable. Right. But a deterministic UUID, that's generated from specific input. So if you feed the same input into the algorithm, you'll always get the same UUID.
So it's like instead of rolling the dice, you're picking your number?
Exactly.
Love
You
that.
got it. And that predictability, that's super useful for programmers.
How so?
Well, imagine you've got two systems offline, both generating data.
Okay.
With deterministic UUIDs, you can make sure that when they do connect, the data merges perfectly.
Oh, because the same IDs were made on each side.
That's it. It's like a built-in synchronization thing.
Very interesting. So John's post focuses on a particular way to create these deterministic UUIDs.
Right.
Using something called UUIDv5.
Right.
Okay, so tell me about UUIDv5.
So it's one of the several versions of UUIDs, and it uses this hashing algorithm called SHA-1 to generate unique IDs.
Okay.
But here's the thing.
Yeah.
It needs a unique piece of info to hash, right?
Okay.
And that's where X.550 comes in.
Oh, so X.500 is like the secret ingredient.
Exactly. X.500 is a standard for directory services. And it gives us this structured way to represent data.
Wait, hold on.
Yeah.
Directory services. You mean like a phone book?
Kinda, yeah. But way bigger.
Okay.
Like a giant organized database with info on all kinds of things.
Okay.
People, organizations, devices, you name it.
I'm starting to see the picture.
Good.
So how does X.500 help us make UUIDs?
Okay, so within X.500, there's this concept of distinguished names, or DNs.
Okay.
They're like unique addresses for each entry in the directory. Yeah, so it's like a digital fingerprint for a piece of beta.
Okay, I get that.
Now, these DNs have a very specific structure to them. They're hierarchical strings that break an entity down into its parts.
Okay.
Like, for example, John Marsh, right? He might have a DN that looks like this. CN John Marsh, OU Engineering, O Red Cat Systems, CUS.
So it's like saying this is John Marsh in engineering at Red Cat Systems in the U.S.
Exactly, you got it. And that hierarchical structure,
Yeah.
that's what makes DNs so powerful for creating these UUIDs.
How come?
Because they're globally unique and standardized.
They can ensure that the same ID gets created for the same entity every single time,
Okay.
no matter where that data is generated.
Wow, that's pretty neat.
Yeah, it's really cool stuff.
All right, so I think that's a great place to stop for today.
Sounds good.
We will be back to continue our deep dive into deterministic UUIDs next time.
Looking forward to it.
So for now, thanks for listening, and we'll see you on the next episode.
Hey! So that's why John really focuses on using these DNs with UUIDv5 in his blog post.
Yeah.
It's such a smart way to use this, this structure that already exists to generate these unique IDs that we know are going to be consistent.
Yeah, it's like he's found a way to bring order to all this crazy distributed data out there.
That's a great way to put it. And this approach, it has some really practical benefits.
Like what?
Okay, so think about it.
Yeah?
You've got data being created offline, right?
Yeah.
Say, on a mobile device.
Okay.
When that device finally connects back to the network.
Right. You want to make sure that any new data just integrates nicely with your systems.
Yeah, you don't want to run into any duplicates or conflicts or anything like that.
Exactly. But with these deterministic UUIDs based on DNs,
Yeah.
you totally avoid those problems.
That's pretty cool.
It is.
Yeah.
Because the same ID is made no matter where the data comes from.
Right.
So you can be sure that everything will sync up without any issues.
That's a huge relief. It's like having a universal translator for data.
Haha. I like that. And it's not all about data synchronization.
Oh.
Deterministic UUIDs, They can also be super useful for content management systems, too.
Oh, really?
Yeah. So think about it.
Right.
You have a blog post.
Uh-huh.
And you want to be sure that all the links to it, all the references, they stay good.
Right.
Even if you move the post to a different spot or change the title.
Right.
The ID stays the same even if the actual content changes.
Oh, okay. So it's about like maintaining consistency.
Exactly. You got it.
And avoiding those broken links.
Avoiding broken links, yeah. And it can also be super helpful for version control systems.
Or you're tracking changes to files over time.
Yes, exactly.
I mean, instead of using file names or timestamps,
Yeah.
which can be messed with.
Right.
You can use these deterministic UUIDs to make like a permanent ID for each version of a file.
That's the idea. And it makes it way easier to keep track of changes, merge different versions together, and just ensure that you've got a clear history of how a file has changed over time.
It's like having a built-in audit trail.
Yeah, exactly.
I'm starting to see how all this comes together now.
Good.
It seems like deterministic UUIDs, especially when you combine them with like X.500 and DNs.
Yeah.
They offer like a really powerful solution for managing data in all these like complex systems.
It's all about bringing order and predictability to a world that's often anything but.
I like that.
Uh-huh.
Okay, so John's blog post doesn't stop there. He also talks about LDIF and base64 encoding.
Oh, yeah. Good stuff.
Can you explain what those are?
Sure. So LDIF stands for LDIP Data Interchange Format. Okay. And it's basically a way to represent directory data, like, X.500 info in a text format.
So like a standard way to move data in and out of directory services.
Yes, exactly.
Okay.
And sometimes when you're using LDIF, you need to encode the raw data.
Okay.
Just to be sure it's represented correctly.
Right.
And that it doesn't cause any problems with the LDIF syntax.
So that's where base64 encoding comes in.
That's exactly right.
Okay.
It's a way to convert any kind of data into a format that only uses these safe characters, letters, numbers.
Okay.
And a couple special symbols.
Okay.
That way the data can be transmitted and stored without any problem.
It's like putting your data in bubble wrap before you send it off.
Exactly. Got to keep it safe.
And that's really important when you're working with X.500 data in this LDIF format.
I see. Okay.
Yeah.
So John also mentions RFC 4519 in his post.
Yes.
What's that all about?
So RFC 4519 is like a rule book for how we show user info in LDIP directories.
It defines a standard way to show things like given name,
Right.
surin for surname,
Okay.
and importantly for us, EZID for user ID.
So it's about making sure everyone's speaking the same language when it comes to user data.
Exactly. Consistency and, being able to work together, that's key for any system that uses user info.
Makes sense.
Yeah.
It sounds like John's really thought of everything with using these deterministic UUIDs with X.500 there.
He really has.
It's like a complete way of addressing the problems programmers face when dealing with data in these systems.
I couldn't agree more. It really shows his deep understanding of the technical stuff and the practical stuff, when it comes to data management.
Totally, yeah. It's really interesting to see how John's post ties all these different ideas together.
I know.
UUIDs, X.500, LDIF, base64 encoding, RFC 4519.
Yeah.
Into like a real solution for a problem programmers face all the time.
Yeah. It's a great example of how really understanding the tools and standards we have can lead to some really elegant solutions. Like, he's not trying to reinvent the wheel.
Right.
Just using it in a new way.
And I really like how he doesn't just like throw the technical details at you.
Yeah.
He explains why it matters.
Yeah.
He really makes a case for why deterministic UIDs are so valuable for, the way we build software today.
You can tell he's been there. He's dealt with these data management problems.
Oh, yeah.
And that comes across in his writing.
Yeah. So John's post focuses on X.500 as the source for these hierarchical DNs.
Right.
But I'm curious, are there other ways to get that kind of standardized, globally unique ID?
That's a great question, and it sort of leads us to this bigger conversation about the future of data identification.
Okay.
X.500 is great. It's a mature standard.
Uh-huh.
But there are these newer approaches popping up.
Like what?
Things like decentralized identifiers or DIDs.
Oh, DIDs. Yeah, I've heard of that.
Yeah.
I'm not really sure what they are, though.
Basically, they're a way to create these globally unique IDs, but they aren't tied to some central authority. So instead of relying on a central directory service like X.500,
Yeah.
you're making a more distributed system.
Wow. And what does that mean for like data privacy and all that?
Oh, that's a whole other can of worms we could open up.
Yeah, maybe we'll save that for another deep dive.
Sounds good.
But it's just really interesting to see how data identification is changing.
I know, it's a constantly evolving field.
All right, so let's wrap things up.
Okay.
What are the key takeaways from John's post that our listeners should keep in mind?
I think the big takeaway is that these deterministic UUIDs, especially when you use them with a standard system like X.500, they're a powerful way to manage data in these complex systems.
It's all about bringing order to what can feel pretty chaotic at times.
Exactly. And it's about realizing that the tools we need are already out there.
Right.
We just need to know how to use them.
And John's post is a perfect example of that.
I agree.
He took these concepts and showed how they can be used to solve a real problem.
Yeah, he did a great job.
So, to everyone listening, check out John's post. Explore these deterministic UUIDs.
Yeah, you might be surprised how useful they can be in your own work.
Exactly. And who knows?
Yeah.
Maybe you'll come up with even more creative ways to use them.
That's what we like to hear.
This has been another great deep dive.
Yes, it has.
And we'll be back to explore more cool topics with you soon.
Absolutely. Until then.
Keep learning, keep experimenting,
and
keep diving deep.
See ya!